Hi, this is Paul Bentley from Lizard NDE, and this is video 4 of the short video collection for lizard inspection and sizing software, otherwise known as LIS. We have previously taken a scan with the LP600 probe. We have tweaked the constants and the zooms to make the signal a little bit easier to identify what's going on. And we have also set up the sizing constant, telling the system that the amplitude of the absolute signal when passed over the LK100 plate is equal to 2 millimeters. And if you remember, this generated a constant number of 415 for me. Okay, in front of me I have a full penetration butt weld on a sample plate. It's actually a real piece of offshore platform that we have here that has a real defect included in the toe of the weld. So now I'm going to show you how to very quickly perform a repetitive scan along the unknown plate so that we can see if we can identify any of the defects. So, first thing I'm going to do is perform an auto adjustment of the LP600 sizing probe when placed onto the welded plate. So I have now placed the probe onto the toe of the weld, and again I can either click A on the keyboard or I can click the transport button down on the right hand side. The probe is adjusting, holding it in place. Now it will ask me to perform the second part of the adjustment, which is the air portion. Okay, now the probe is ready to go. So again, I can either click P as the hotkey, or I can actually click the repetitive scan button. Now the repetitive scan will take a scan for the duration of 10 seconds and then refresh the screen, and will continue forever. So if I click repetitive, you will see what I mean. So repetitive. Okay, now I'm scanning down the toe. All very flat, nothing there. And you see the display has refreshed, and it will keep refreshing forever until I stop. Okay, so I've run up and down the weld, pretty much nothing there to see. I now move to the other side of the weld. Let's just wait for that to refresh. So I scan down the weld, see if you can see any of the defects. Aha, we have an indication. Okay, so now I'm just going to go backwards and forwards over that indication region to identify that yes, actually we do have an indication there. I can see that we have an indication due to the impedance, correlation, BX and BZ on the time base. Okay, so I'm going to abort that. Now I know that I have a defect and where I should be looking for. I can now take a scan and this time put markers onto the data, so I have a reference of the position for the defect. Markers is also required to perform the full sizing, because obviously we need to know the length of the defect, not just the depth. So therefore I have to have some reference on the data to give me an indication of what the length of the defect will be. If you remember yesterday, I did say that you do not need to know the length of the defect in order to generate the depth information. Those two are completely separate with the lizard system. So I'm going to perform another auto adjustment to ensure I get the best signal I can from my probe, and in that way I use the hotkey from the keyboard. Lift the probe off again. Okay, now I'm going to perform a scan, and this time I'm going to put very basic markers in just by using the keyboard. So 3, 2, 1 to take a scan. Okay, now these markers are being input at every 50 millimeters. Right, now I have a scan of the data. If you look carefully, we have liftoff on the impedance defect. We have a correlation loop. In fact, we actually have two. We also have the BX relatively flat along the duration of the scan until we get to this portion here where we have this initial bump in the scan followed by a second one, and on the CP again relatively flat until we hit this position here where we have start stop information from the defect. You'll notice on the liftoff was straight and very well coupled all the way to the duration of the scan until I lifted off at the end. Okay, so now whilst we're here, let's save the data. So another feature is the notepad in the data file. So we've taken the data file but we haven't saved it yet. If I click on text, this now brings me up a notepad function that's in the Lizard M8 software. This notepad we can pre-configure by typing in these boxes, and then when we want to use them again, when we click on the drop down, that input will already be there ready for us to just click as a time-saving method. So we have, let's see what else we have in there. Nothing in there at the moment. So the world length, let's say it's 300 millimeters. Marker interval was 50 millimeters. Okay. Then we have other options to put the probe type, component, etc., etc., etc. And we also have some freeform text that we can add in here. When we click save, it now brings up as a straight into a Windows environment, and we choose where we're going to save it. Well, I'll just save it to the desktop for now. One important thing to note is that when we are saving a data file using the Lizard's list inspection and sizing software, we do have to add a suffix to the file type, file name of .100 or up to .999. Okay, this is a part of the Lizard list software that ensures that it's still compatible with data files from previous DOS versions of the software. Okay, so now if I click save, I've now saved that file and the text that is associated with that file. Okay, in my next video we will take this data file and we will actually size this defect. Okay, thank you.